The question of the hour, are these two lines, L1 and L2, parallel, orthogonal, intersecting, or skew? Let's start at the top. Parallel. If my two lines are parallel, that means their direction vectors are equal or are scalar multiples of each other. So let's try it out. For L1, we can read off the direction vector here from looking at the coefficients of the t's, 1, 3, -1. And for L2, 2, 1, 4. Well, they're not the same, and they're not scalar multiples either. So for parallel, that's a big no. They're not parallel. Let's try orthogonal. I know that if two lines are orthogonal, then the dot product of their direction vectors should be 0. Let's give that a try. If I do the dot product, 1, 3, -1 with 2, 1, 4, I get 2, 3, 2 plus 3 minus 4, which is 1, which is not 0. So that's a big no on orthogonal too. So either they intersect or they're skew. Well, if my lines intersect, then there's a point somewhere out there in space where the x coordinates are the same and the y coordinates are the same and the z coordinates are the same. Because it's the same point on both lines. Let's start with x and y. If the x coordinates are the same, that means 1 plus t equals 2s. If the y coordinates are the same, that means -2 plus 3t equals 3 plus s. That's a system of equations, two variables. We can solve that. If I rearrange a little bit, and you can substitute or do a little elimination, whatever works for you. If we work our way down, this is like those baking shows where they pull a beautiful finished cake out of the oven 2 minutes after they put the other one in. If I solve this system of equations, I get t equals 11/5 and s is 8/5. It is my assumption that anybody who cares enough to watch this can solve a system of equations in two variables. Well, so there is a place where x and y are the same. Now the question is, when x and y are the same, is z also the same? So now I got to try 4 minus t and see if it equals -3 plus 4s with these values of s and t. Let's find out. 4 minus 11/5. Is that the same as -3 plus 4 times 8/5? It's not looking good. 4 minus 11/5 is 9/5. -3 plus 32/5. 32 minus 15 is 17/5. And that's a big no also. So it looked good for a minute. We found s and t so that my x and y coordinates were the same. But when x and y are the same, z is different, which means they don't intersect. Which only leaves one possibility. These two lines must be skew.